Hey everybody, today we're going to be working on a Tesla Model S motor. And I'm going to show you how you can make it over twice as fast. So you might be wondering, why would you need to go more than twice as fast? In case you're breaking a land speed record. Or in my case, in case you're putting in a truck or a Jeep. So in the case of this Jeep, the rear axle actually has a differential which has a 3.7 to 1 gear ratio. That means for every 3.7 rotations of the motor, the back axles or the wheels actually go 1 rotation. So the Tesla has its drive geared for, I'll call it like a direct drive. That means the whole drivetrain is geared towards good launch all the way up to freeway and even up to about 120, 150 miles per hour. If you use the motor transversely, like I'm planning, to connect the drive to the differential, that means at full speed, that 150 miles per hour is divided by 3.7. That gets you down to about 50 miles per hour for top speed. Today's sponsor is AstroAI, but more on them later. So to get us back to freeway speeds, we need to change the gears in the Tesla. Follow along and we'll do it together. The Tesla motor actually spins up to 18,000 RPMs. This does have a transmission of sorts. People think of a transmission as kind of shifting gears, but this is really just a gear reduction, and it's about a 9 something to 1 gear reduction. So meaning every 9 rotations of the motor, the output shafts give 1 rotation. The Tesla motor is really geared and made to do that quick acceleration. However, the top speed kind of really is limited, maybe 120, 150 miles an hour for the Model S. So today I'm going to take this apart, put in some new gearing that will give us over twice as fast.
All right, this is all we need to make the swap. We got a couple gears, and there's a retaining ring. But this set I got from Felton, and this is a 4-to-1 gear reduction. All right, I'm used to taking off the inverter cover. We don't need to do that this time. We just need to split it in half to access the gears. One of the first things we need to do is take off the electrical cover for the 3-phase connections underneath. Normally you'd want to drain all the transmission fluid before. I've worked on this one once and it's already been drained, so there shouldn't be much in the way of fluid coming out. So it really helps to have a lift or something to get to the bolts on the bottom, but you can just kind of roll it and do it. But having lifting equipment definitely helps. The housing here has enough spacing differences that you need a short and a long socket. So here you can't do a long one. Some of these other ones you can't do a short one because things run in the way. They didn't really put any pry slots, so you just have to find kind of a proud spot on the outside of one of the kind of bolt holes. There. All right, here it is in the inside. Again, not a lot of fluid because we'd used this one once before. All right, this is probably a good time to show the difference here. So put a little red dot at the top there, red dot up there. So this one, when we go 1 time around, it's barely moved at all. So if we go 2 times around, then 3, 4, 5, 6, 7, 8, 9, and then it's like 9 point, I can't remember, like 6 or something. There's like 9.5, 9.7 maybe, looks like about what it is. So when this one spins 18,000 RPMs, this one does not. So what we're going to do is we're going to swap out a couple gears here to make this one spin even faster. There's 2 seals or maybe more you have to take note of. So there's one, and here's the other one. There's actually another one right here, but for me it usually stays in. So we just want to make sure we don't lose these. We got to clean up all the gasket material so we can apply new gasket material. All right, I'm getting this pretty clean. I found that they call it the magic eraser. Seems to take off the gasket material pretty good. So I'll just give you a little close up here. So that's kind of the leftover material. I'll scrub for a second and you'll see the results. And basically right here, it's all gone. All right, we've cleaned up the surface pretty well. We're now going to take out the ring gear so we can kind of get these gears out. There we go. go. All right, here is the main ring bearing. We actually have already put a limited slip differential on this one. So we're gonna keep this one exactly as is, but we need to remove these two. And I'm not exactly sure, I don't know that I've really ever seen anybody do this, but it looks like there's holes. And if you kind of spin them, then you can line them up with those. And that's gonna be, I think, the retaining ring for the bearing. So I'm hoping if we loosen those, this whole thing can just slide out. Oh, there it goes. All right, so here's that gear set with the bearing and the retaining ring. So again, this one we won't be using anymore. Looks like this is just slightly in the way. Whoa, was not expecting that. So this is the gears coming off of the motor directly, and there's a ton of rust on that one. Was not expecting any rust here. And look at all the rust that was in there. That's just an insane amount. So today we have a portable car air pump. All right, so it looks like we've got some accessories here. Fill up anything from like a ball to tire to an inner tube, charging cable. Look at that, that looks really good. So for size purposes, it's maybe just a little bit bigger than a cell phone. It's obviously thicker than a cell phone, maybe like 3 cell phones. But again, very small, very compact. So it gives you the PSI. Oh, it's got a light. Love that. Flashing red, faster flashing red, or off. You can switch to car, motorcycle, bicycle, basketball. You can easily go up or down. This can act like a power bank. It has a battery of 6,600 milliamps. So it does have a max 150 PSI rating. It can refill a pretty standard car tire that's at 30 PSI to 36 PSI in 90 seconds. So let's go find something to inflate. So I used to always have a low tire pressure on my black car, but I actually recently got that tire fixed. So we're gonna check the Jeep, see if it's got any low tires. First tire, it says 30. Let's see how fast it goes to 36. All right, just started the timer at 2 seconds. The operation is fairly quiet at 80 decibels. So I always think these products are great to have in emergency situations. So if you're stranded at the side of the road, you've always got power for your phone, you've got a flashlight and a strobe light, and maybe most importantly, you can fill up your car tire. Just right around 2 minutes, we're all the way full. So this tire inflator is on sale right now. It's less than 40 bucks. So if you're interested in a product like this, I'll leave a link in the video description below. So this is the one that came with the car. We need to get this bearing off of this one and onto this one. Similarly, the bearing from the car onto this one. So we just need to swap those real quick, and then we can start the reassembly process. So this one looks like it's like on the suspension coilovers, things like that. So this one looks like it twists off. So we'll see if I've got something that can get that off. All right, so for this one, this retaining ring requires a special like spanner wrench that I don't have. So that one needs to come off, the bearing needs to go in here, and then it needs to be screwed back on. So I'm gonna see, I've got a friend that's got a plasma table, and see if he can cut me a tool real quick. But in the meantime, we'll get this one ready. It's just all the rust that came off. Maybe it's not rust, but I think it's rust. So we'll go ahead and get the bearing off this one, put it on here, get it all ready. All right, so I got a friend with a plasma table, so we cut out a specialty tool. So I'm pretty sure it was a red Loctite, but man, that was really stuck on. But we got it off. Next is, will the bearing easily come off? So this bearing, I used kind of a bearing puller that I have got, and it does not want to move. It's very much stuck. And this one, it really doesn't have like a lip there. So I tried just putting it on some metal rectangular tubes and then put the press on this to see if it would budge. It did not budge either. I think if I would have known how inexpensive the bearings were to begin with, I would have just done it the way that I'm doing it now, but I bought some new bearings. So basically a bearing to replace this one and a bearing to replace that one. So these are both just gonna stay where they are, and the new bearings are gonna get onto their new pieces, that one and that one. So these are SKF bearings. Basically that's just we're replacing the bearings that are already there. 6308 and a 6208. So I'm gonna do some quick dimensionals on this and that one, make sure they're the same, as well as this one and that one. Again, they've got the number right on them, but I always worry that somehow I messed something up. They look exactly the same, which is a good thing. So right at 80 for the OD, yep, 80. Looks like 40, which is what it's supposed to be. And then width is 18. So this one is ready to go in there. 90, 90, 23, yep, 23. We are good. The idea of this is 40 and 40. So I think we're good. Everything matches. So I think what I'll do is I'll put the bearings in the oven, kind of heat them up quite a bit, and throw the gears and things in the freezer. Hopefully things will go together a little better if we do that.
So I'm gonna use a special tool to help me with these bearings and gears.
This is the HF96V, which is a thermal camera.
Has a wide temperature range from -4 Fahrenheit all the way up to over 1,000 Fahrenheit.
Oh yeah. Oh yeah, look at that. I love this stuff. So you can kind of see everything in here.
One of the things I always think is interesting is like the floor, it's like 10C, maybe 8C says the min, but you know, right where I'm aiming is 10C. And if I go up to the ceiling, it's like 15C.
All right, I've seen this before. We're gonna go ahead and try it. So we're gonna go ahead and bake some bearings at 300. Similarly, we're gonna throw these gears in the freezer.
So this has a built-in 96 by 96 IR camera and a 640 by 480 visual camera. So you can do a visual, a thermal, or a fusion mode. So it's got this trigger here, and basically you just pull that trigger to capture an image. It has this USB on top that you can connect to a computer to download those images or screencast to that device.
All right, you know what we're looking at? Got some bearings heating up. So that way you can tell if they're up to temperature or not. Same thing here in the freezer. Can you tell where the bearings are? All right, I'm going to take things out and try and put things in. Huh, works great. Perfect. Okay, one down, one to go. 2 for 2.
It has an advanced VOX sensor and can detect temperature differentials all the way down to 0.5 degrees Celsius. So actually in the shop, I end up using something like this quite a bit just to check to see if things are cool.
You may remember this from a few episodes ago, but these ones are just welded. We'll see what they look like. They're nice and toasty.
It came in very handy for things like when I was doing the 1958 MGA, we caught some issues, some electrical issues that could have been very bad for us. These are some pretty cool images, right? This is with a thermal camera. So I highly recommend getting something like this. If you're interested, I'll leave a link in the video description below.
All right, the bearings are now cool. Everything's in place. So now we've got to start the reassembly. So first is this ring that goes on here. We're gonna go ahead and put some thread locker on, tighten it up the best we can, and then we'll start putting everything back in the motor. To be honest, I don't know why they have this ring on. I mean, this bearing does not come off. It is very much on there, but we're gonna put it back just because that's how it was. I think we may need to modify this nozzle. Let's just see real quick, because I think it just pokes out a little too much. Just take it out for a second. Guess it would help if I put it in the right way. So the head type here is not conducive with the space that we have. So I'm going to look to see what we can do to get the same threads, but different head. I'm just going to try and use the screw here. So it's again a little bit lower profile. I think we can do it. Let's give it a try and see if we've got clearance. So what I'm going to do, right now we've got a lot of room. So I need to scoot it in just to the point where these can barely fit in, because these are too long. So if it's all the way up against there, it's too long and you can't kind of fish them in. So you actually have to get these somewhat in place, kind of part way. Come on, dude. All right, I think that's maybe close enough. All right, so I've just got them started. There's one there, and then one there. So you can see that like you can't really drive them from straight ahead, and there's not a lot of clearance. Like if you wanted to get a closed end wrench, you know, if this was a low profile hex, that might work. But there's not a lot of room to like actually get something in because all this is behind this surface. So we'll see if we can keep going, get this thing tight. You'll have to tell me if I'm the only one that does this. When you buy something that has tools to help you assemble, like an Allen wrench, I tend to save those just for some random occasion. Today is that occasion. I'm gonna make a very, very short wrench to help me with this assembly. So we'll see if that's short enough. So I've got those ones tightened down. I think you maybe could have reused these. So head height's just pretty close, but you could have used these. The challenge for any of these is to figure out how you're gonna tighten it. So I kind of made myself a very, very short wrench that could get in there and tighten things. But yeah, that's good, it's tight. So the next thing is we're gonna tighten this one and put on the little retaining clip. All right, we got the retaining clip in, and that's really just so that screw cannot back out. So next we got to address this one, which has this little tip that's too long. So this piece I need to kind of shorten to about where my finger is there. I'm going to try and give it the same profile, kind of get the same spray pattern. We'll see how good I can do. All right, so here's the piece, and basically we just need this to be cut off just a little bit. I've already kind of measured and got the right drill bit to kind of re-drill that hole. It's even got a little slot to the side. I think it kind of sprays out. I'll call it like a sprinkler. So I'm going to use the same thing when it's hot to kind of create that same geometry if I can. All right, so I've got this shaved down and melted over, so it's kind of complete dome now. I just need to put in that hole, and I'll kind of do that little cross pattern as well. All right, so it is plugged on the top. I do have a hole there. I put a little notch in as well to try and match the original geometry. We'll go put this in place. There we go. That was easy. Let's put that one at the top. Put this one at the top. This will confirm new ratio. So there's 1, and it's about 1/4. So it should be about 4:1. So there's 2, 3, and 4. So we are back to dead center. So again, this new one is a 4:1. Previously, it was like 9.7:1. All right, so next up, we've got the retaining ring for this bearing. I got to get those nuts back on. Then I got to make sure the sealing surface is completely clean. I will put a new bead of the gasket maker on, and then we can start putting things back together. All right, we've got this mostly buttoned up. I've not torqued everything down. The gasket material we're supposed to kind of let set up for, I think it's 24 hours. Then we'll torque all these bolts to their torque specs. But we've got everything basically put back together. I've even got our new prop shafts on. These are gonna go to the new drive shafts that we're making. This one is designated for the Jeep. So again, we are now able to go back to freeway speeds with the Jeep.
So that's going to do it for this episode. This is how you can make your Tesla go twice as fast. Thanks for tuning in. See you next time.
I need to sneeze. Oh, there it goes. Do I have another one coming? Maybe. Oh my goodness, twice. Okay.